Good morning, my YouTube viewers. It is Crystal here. I'm here this morning to give you another code review. Basically, in my last video, we were working on Kaggle's Playground Series Season 4, Episode 1, and I used sklearn's random forest to find the probability of whether a customer would churn or not. And basically I got 87% on that model. Well, this model, what I'm going to do is I'm giving you a code review of this model because I got a bronze medal on it. I'm not sure exactly why I got the bronze medal because I scored better on random forest than I did Jack's linear regression, but maybe they gave me the bronze medal because I was exploring an alternative technique and an alternative library because I was using Jax. Jax is a library made by Google, and they say that it's supposed to surpass TensorFlow, and it's used for research. So I'm not sure exactly why they've got Jax and TensorFlow, but there's a lot more written about TensorFlow than there is Jax, and that's why I've been using Jax to try to get the code out there, to get Jax code out there, because there's not a lot of code available. So now that you know a little bit about Jax and a little bit why I believe I got the bronze medal, we will commence with the code review. So we use binary classification with the bank churn data set, and that is Kaggle's Playground Competition Series 4, Episode 1. We go through the problem statement. The problem statement is identify the probability that a customer will churn. When a customer churns, it means that they leave that company and they go on to another company. And then what we're going to do after we have developed our problem statement is we're going to import our libraries. So we're going to import NumPy as NP, which creates your NumPy arrays and makes numerical computations. We're going to import pandas as PD, which creates your data frames and processes the data. We're going to import Jax, which is going to create your model, and Jax is supposed to surpass TensorFlow. I read that somewhere in Google. We're going to import OS, which is going to go into the operating system and retrieve the files that you need to execute the program. We're going to import sklearn, which gives you machine learning functionality. We're going to import matplotlib, which helps you to visualize the data. And we're going to import Seaborn, which helps you to statistically visualize the data. So after we have imported our libraries, we're going to use the OS library to go into the operating system and retrieve the files that we're going to use to execute the program. The three files that we have are train, test, and sample submission. Then we're going to use pandas to read the data sets in, and when we read the data sets, we're going to convert them to data frames. It's going to be train, test, and submission. So you can see the train file here, and it has 14 columns of data, the last column being exited, which is your target. Look at test. Test is similar to train, except for the fact that test does not have a target. We're going to be making predictions on the target. We're going to be making predictions on the test set. And then we've got submission. This is what Kaggle wants to see when we submit our data. So the first thing we're going to do is we're going to drop the ID, the surname, and the customer ID. The reason why is because those are kind of like identification for the row of data, but when you are